Hi, I'm Steven Martinez, and these are my KSP Quiz Corrections. So for A1, we have to write the equilibrium constant expression for the reaction, and the equilibrium constant expression is KSP is equal to PB plus 2 times I minus squared, and I minus is squared since there's a 2 in front of the I minus in the balanced equation. For A2, we have to calculate the molar concentration of I minus in the solution. So all we have to do is multiply the concentration of Pb plus 2 by 2, since for every mole of Pb there's 2 moles of I minus, and we get I minus is equal to 2.6 times 10 to the negative third molarity. A3, we have to calculate the value of the equilibrium constant KSP. So we just plug in the values of Pb plus 2 and I minus into the equation from A1, and we get 8.8 times 10 to the negative ninth is equal to KSP. For B, a saturated solution is prepared by adding PbI2 solid to distilled water to form 2.0 liters of solution at 25 degrees Celsius. What are the molar concentrations of Pb plus 2 and I minus in the solution? So, if distilled water was added to the saturated solution to form 2.0 liters of solution, the concentrations of Pb plus 2 and I minus wouldn't change since the solution is still saturated. For C, solid NaI is added to the saturated solution of PbI2 at 25 degrees Celsius. Assuming that the volume of the solution does not change, does the molar concentration of Pb plus 2 in the solution increase, decrease, or remain the same? So, Pb plus 2 would decrease since the increase in A minus ions will shift the reaction to the left towards PbI2 solid. For part 1 of D, we have to assume the volumes are additive and calculate the molar concentrations of Ba2 plus and CrO42 minus in the 1.0 liter of solution. So, we take the molarities of Na2CrO4 and BaNO32 and we have them, and since they're equal, we get both of Ba2 plus and CrO42 minus are equal to 4.1 times 10 to negative 6 molarity. Use the molar concentrations of Ba2 plus ions and CrO42 minus ions as determined above to show why precipitate does not form. So we take the molarities of Ba2 plus and CrO42 minus and we multiply them together and we get 1.7 times 10 to negative 11, which is equal to Q, so a precipitate does not form since Q is less than KSP.